Okay, welcome to this session. As you can see, the title is Mechanisms of Tapering to Enhance Performance. This follows on from previous sessions as part of this series, which have addressed the notions of periodization, supercompensation, training variables, the previous sessions that have looked at recovery, regeneration, and theories and models of training. So if you haven't been through the previous sessions, particularly those related to fatigue and periodization, it's worth going back to those before embarking on this particular session. So what are we going to cover? Well, this session fundamentally focuses on what is a taper and how we define an appropriate taper regime. And we'll discuss what we mean by an appropriate taper regime as we go through. We're going to examine the physiological consequences of applying a controlled taper, and fundamentally the bit that goes with that is what are the performance outcomes. So we can separate the physiology in many ways from the performance and see what the concomitant outcome is. We're going to start with a little bit of a kind of a quiz for you to kind of get you warmed up as you go through the session. So taking some paragraphs here from a reasonably recent paper by Spilsbury and colleagues. It's published about 9 years ago. But they write this, and I want you to kind of fill in the blanks as we go through. Elite athletes engage in training overload to stimulate adaptation for the benefit of performance. During high volume training phases, recovery is blank, which can lead to accumulated blank that can impair blank and performance. To blank fatigue, it is common to undergo a period of reduced training prior to competition known as a taper. So what do you think those blanks are? Well, as we can see, it reads as such. During high volume training phases, recovery is limited, which can lead to accumulated fatigue that can impair physiological adaptation and performance. To abate fatigue, it is common to undergo a period of reduced training prior to competition known as a taper. And again, same principle. The aim is to maximize blank whilst eliminating accumulated fatigue and retaining or further enhancing blank. So what do we think the missing sections are here? Well, the aim is to maximize physiological adaptation whilst eliminating accumulated fatigue and retaining or further enhancing performance. Tapering can be achieved by manipulating the training load variables of blank, big one there, over a given duration, with blank relating directly to individual maximal aerobic capacity, heart rate, or race pace. So what do we think are under there? Well, tapering can be achieved by manipulating the training load variables of volume, frequency, and intensity over a given duration, with intensity relating directly to individual maximal aerobic capacity, heart rate, or race pace. And finally, the taper has been recently redefined as a progressive nonlinear blank of the training load during a blank period blank in an attempt to reduce the blank ological and blank stress of daily training and optimize blank. It's worth just thinking about this. This is from a different paper. This is not from the same paper. But it's this. So the taper is recently defined as a progressive nonlinear reduction of the training load during a variable period of time in an attempt to reduce the physiological and psychological stress of daily training and optimize sports performance. So if we dig into that, this is a definition from a textbook published in 2009, which is actually kind of using paper from Muika, published in 2003. And it kind of sets in stone, if we take what has been covered in those previous slides in terms of setting it up, that it's a non-linear progressive reduction. It's about bringing physiological and psychological recovery. It's about optimizing performance. We then kind of have a notion of what a taper may well be doing and is constituting. Well, if we dig into this little paragraph here, it perhaps helps helps us a little bit more in our discussion of this. So, the athlete's peak is brought about by use of a taper, which can be summarized as a training phase prior to competition, containing a progressive reduction in training load to allow for optimal physiological and psychological recovery, as we saw in those previous slides. Tapers vary between 7 to 21 days in length, during which time the training load is reduced, but training intensity remains at around 90% of the pre-taper value. And that's a really important starting point, that fundamentally we are reducing training load. Remember that what we're trying to do is we're trying to reduce fatigue, we're trying to bring about physiological and psychological adaptation, and we're trying to get an acute change in the athlete preparedness. But the key thing is, and it might sound counterintuitive, is we have to keep the intensity pretty high, even if this is a 21-day period taper. And we'll explain why that is the case as we dig further into this material.